Intro. Welcome back to our channel. Today, we're going to dive deep into the fascinating world of artificial intelligence, specifically focusing on how to build a production-ready AI workflow. This is an essential topic as businesses increasingly rely on AI to streamline their processes and drive innovation. We'll be covering the entire lifecycle of an AI project, starting from data ingestion and going all the way to model deployment, and we'll be highlighting the role of AutoML tools throughout this process. So if you're an aspiring data scientist, an AI enthusiast, or even a seasoned professional looking to refine your skills, stick around. Let's get started. What is a production-ready AI workflow? Before we get into the nitty-gritty of building an AI workflow, let's clarify what we mean by production-ready. A production-ready AI workflow is one that is robust, scalable, and capable of serving real-world applications. It should be able to handle incoming data seamlessly, train models efficiently, and deploy those models in a way that they can be accessed and utilized reliably. In short, it's not just about building a model that works, it's about making that model work in a real-world setting with all the complexities that entails. Step 1. Data ingestion. The first step in any AI workflow is data ingestion. Data is the lifeblood of AI, and without the right data, no algorithm will be effective. The data ingestion process involves collecting, processing, and storing data from various sources. This could include databases, APIs, web scraping, or even IoT devices. The key here is to ensure that the data is relevant, high quality, and ideally labeled if you are working on supervised learning tasks. One popular method for data ingestion is using ETL, extract, transform, load, processes. With ETL, you extract data from different sources, transform it to fit your needs, cleaning, normalizing, or aggregating, and then load it into a storage system such as a data warehouse. There are several tools available for this process, including Apache Kafka, Apache NiFi, and Talent, which can automate much of this work, making it easier to handle large volumes of data. As you build out your data ingestion pipeline, it's crucial to keep in mind the importance of data governance. This means ensuring that your data is compliant with regulations such as GDPR or CCPA and that you have the necessary permissions to use it. You should also implement logging and monitoring to keep track of your data ingestion processes, helping to catch any errors or anomalies early on. Step 2. Data pre-processing. Once you have your data ingested, the next step is data pre-processing. This is where you prepare your data for modeling. Data pre-processing can include a variety of tasks, such as handling missing values, encoding categorical variables, feature scaling, and splitting your dataset into training and testing sets. AutoML tools can be particularly helpful in this phase, as they often include built-in pre-processing capabilities. For example, platforms like Google Cloud AutoML and HowToAI have automatic handling of missing data and can suggest appropriate transformations based on the dataset's characteristics. This not only speeds up the pre-processing phase but also ensures that the data is prepared effectively for model training. Feature engineering is another critical aspect of data pre-processing. This involves creating new features from existing data that might provide additional insight into the problem at hand. AutoML tools can assist here as well, using algorithms to automatically generate features that can enhance model performance. However, it's essential to balance automation with human expertise, as domain knowledge can significantly improve feature selection and creation. Step 3. Model training. With pre-processed data in hand, we move on to model training. This is where the magic happens, as the algorithms learn from the data. Traditionally, this stage required a deep understanding of various machine learning algorithms and hyperparameter tuning to achieve optimal results. Here's where AutoML truly shines. AutoML tools are designed to automate the model selection and hyperparameter tuning processes. They can evaluate multiple algorithms, choose the best performing ones, and fine-tune them without requiring extensive coding or machine learning expertise. For instance, platforms like DataRobot and Azure Machine Learning provide user-friendly interfaces that allow you to drag and drop datasets and specify your target variable. The AutoML engine then performs the heavy lifting, trying out different models like decision trees, random forests, and neural networks to find the one that performs best. Moreover, most AutoML tools provide a wealth of metrics to evaluate model performance, such as accuracy, precision, recall, and F1 score. You can easily visualize these metrics through dashboards, making it easier to understand how your model is performing. This not only simplifies the process for those less familiar with machine learning but also accelerates the workflow, allowing you to iterate quickly. Step 4. Model Evaluation. After training, the next step is model evaluation. This is a critical phase where you assess whether your model meets the business objectives and performance criteria set at the beginning of the project. You'll want to use a separate validation dataset that the model has not seen during training to avoid overfitting. During this phase, you'll also want to look at various performance metrics. Depending on your specific use case, you might prioritize metrics like accuracy for classification tasks or mean squared error for regression tasks. AutoML tools can help you generate confusion matrices, ROC curves, and other visualizations to make this evaluation clearer. Additionally, it's essential to consider business metrics and not just technical ones. How does the model impact the business? Does it lead to increased revenue, reduced costs, or improved customer satisfaction? By aligning your model evaluation with business objectives, you ensure that you're working on solutions that deliver value. Step 5. Model Deployment. The deployment phase is where your model goes live and starts delivering value in real-world applications. This step is crucial because it involves integrating the model into existing systems and applications. There are several deployment strategies to consider, including batch processing, online inference, or even edge deployment depending on your use case. AutoML tools often provide streamlined deployment options, allowing you to deploy your model with just a few clicks. For instance, platforms like Google Cloud AutoML allow you to deploy models as REST APIs easily, making it seamless to integrate them into web or mobile applications. This is particularly valuable for teams that may not have extensive DevOps or software engineering resources. However, deploying a model isn't just about making it available, it's also about monitoring its performance once it's in the wild. This is where model monitoring comes into play. You'll want to track key performance metrics over time to ensure that your model continues to deliver the expected results. If the model's performance starts to degrade, you may need to retrain it with new data or fine-tune it based on changing conditions. Step 6. Maintenance and Iteration. Finally, we reach the maintenance phase, which is often overlooked but is crucial for long-term success. An AI model is not a one-and-done solution, it requires ongoing monitoring, evaluation, and refinement. As new data comes in, your model may need to be retrained to adapt to changing patterns. AutoML tools can facilitate this process by automating retraining schedules or providing alerts when performance dips. Regularly reviewing the model's metrics and updating it based on new data helps ensure that it remains effective and aligned with business goals. Being proactive in this phase also allows you to take advantage of advances in technology and new algorithms. As the field of AI evolves, newer, more efficient models may emerge that could outperform your existing solution. Staying aware of these changes and iterating on your model is key to maintaining a competitive edge. Conclusion. And that wraps up our exploration of building a production-ready AI workflow, from data ingestion all the way to model deployment and maintenance. We've seen how AutoML tools can simplify and accelerate each step in this process, making it more accessible for businesses of all sizes. As you embark on your own AI projects, remember that the key to success lies not just in the technology but also in aligning your efforts with business objectives and ensuring that you have a robust, iterative workflow in place. Thank you for joining us today. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and turn on notifications so you never miss an update. We'd love to hear your thoughts, experiences, or questions in the comments below. Until next time, happy modeling!